Hello, this is Mr. Henry and welcome to lesson 1.2. Compare and order rational and irrational numbers. The central question says, how do I compare and order rational and irrational numbers? So in the last lesson, we learned what makes a number rational or irrational. Rational numbers you can write as fractions, irrational numbers you cannot. In this lesson, we're going to be taking those numbers and trying to compare them to see which ones are bigger or smaller. Put them in order from least to greatest, those sorts of things. So we have a Collins writing for our warm-up. So it's lesson 2, type 1, and you'll have 2 minutes. So it says here, write for 2 minutes on if you feel it is easier to compare 2 decimals or 2 fractions, and why. So it's an opinion, but you have to back up your opinion. So do you feel it's easier to compare 2 decimals or 2 fractions? And give a reason of why. So go ahead, pause the video, do that. When you're ready to continue, hit play. Alright, so hopefully you did your Collins writing. My personal opinion, I like comparing 2 decimals. I think it's a little bit easier. Vocabulary, we have 2 vocab words, and these are the same vocab words as the last lesson. Nothing new. First one says a rational number is any number that can be written as a fraction. This includes integers, repeated decimals, and terminating decimals, which we looked at in the last lesson. An irrational number is a number that you cannot write as a fraction. It can't be done. Numbers like pi or a square root of a number. If you hit a number and hit square root and it gives you a big ugly decimal, that's irrational. That decimal actually will never stop and never repeat. Now, the next piece here we're talking about perfect squares. Okay, let's do this now. So what I have here is I have the numbers 1 through 15 listed, and they're also on your note sheet, 1 through 15. And what we want to do is we're going to take each of these numbers and we're going to square it. So we're going to take 1 times 1. 1 times 1 is 1. And we're going to do that for each of these numbers. So we're going to take 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Let's keep going. So we got 25, 36. And if you know these all off the top of your head, that's awesome. 49, 64, 81, 100. Let's see, 121, 144. This is about where I start to get lost a little bit. Most people only remember up to their 12s. 13, I believe, is 169. Let's double check it. 13 times by 13 equals, yuppers. Since I have my calculator up, 14, 14 times 14 is 196. And 15 times 15, I believe, is 225. 15 times 15 is 225. Now, this is going to be useful later on when we're talking about these square roots, if we're trying to find perfect squares or not perfect squares, to tell if a number is rational or irrational. So this is just a little chart just to give you some background information, just a reference you can look at periodically throughout the lesson when you need to. So the first part of the problem here says we want to estimate the value of irrational numbers without using a calculator. So my calculator, I'm not going to pull back on the screen at all. But I want to know this square root of 19. What is that number about? I mean, is it close to 2, 3, 4, 5? Is it close to 20? I don't know. That's why that chart we just made comes in handy. So let's take a look here. So we're looking for square root of 19. So these numbers down here are the numbers that you would square root to get the top number. So for example, the square root of 81 equals 9 because 9 times 9 is 81. Well, the square root of 19 is someplace between here. It'd be like right in there. So I'm going to say square root of 16, square root of 19, square root of 25. These were the two perfect squares that are around 19. So 19 would be in here, so there's 16 and 25. If I take the square root of 16, I get 4. If I take the square root of 25, I get 5. So this square root of 19 would be someplace between 4 and 5. So all you really have to do is ask yourself, well, is it closer to 4? Is it closer to 5? Or is it almost smack dab in the middle? Well, this is 3 numbers away. This is 6 numbers away. So I would say this 19 is closer to 4. So I'm going to say this is about 4. It's not equal to 4. It's about 4. It's approximately 4. Now, just to show, yes, I'm going to pull my calculator up just to give you an idea what we did. If I take 19 and I square root, it's like 4.35. So that's about 4. It's close enough. That's usually going to be good enough to do the problems that we want to do. We're not going to ever get close enough to do 4.35 on our own without a calculator. We're just trying to ballpark between like 4 and 5. This next one, square root of 27. Now, I know this off the top of my head. You may not. The two perfect squares that are around 27 are square root of 25 and square root of 36. 27 will be right in here between 25 and 36. Square root of 25 is 5 and square root of 36 is 6. So this square root of 27 is definitely much closer to the square root of 25. It's only 2 numbers away here, where that's like 9 numbers away. So I'm going to say this square root of 27 is about 5. It's approximately 5. It's close to 5. We're just estimating. We're not trying to get exact. But using those perfect squares can get you close. Letter C. So we're looking for the square root of 99. Well, it's not one of our perfect squares, but this guy is really darn close. So 99 falls between 81 and 100. So square root of 81, square root of 99, square root of 100. Square root of 81 is 9. Square root of 100 is 10. This square root of 99 is almost 10. It's right next door to square root of 100. It's pretty far away from 81. So I'm going to say this square root of 99 is about 10. It's probably like 9.9 something. 99 square root 9.949. That's really darn close. I'd like you to do the same procedure for letter D. You're trying to approximate. You're trying to estimate. What is the square root of 45? Pause the video. Do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay. So, square root of 36, square root of 45, and square root of 49. I hate when it does that. So, let's see here. Square root of 36 is 6. Square root of 49 is 7. So the square root of 45 is someplace between these two. So it's 6 point something. Now, is it closer to 36 or closer to 49? Let's see. This is 4 numbers away. And between 36 and 45 is 9 numbers away. So I would say it's closer to 49, so this guy is about 7. And there we go. So square root of 45 is about 7. Square root of 19 is about 4. We now can give us roundabout answers that would help us if we're trying to put numbers in order from least to greatest. Example 2. In our goal of being able to put order numbers from least to greatest, here the question asks us to plot each point on the number line. So I need to figure out, for example, where 9.8 would be and where this 4 square roots of 8 would be. So 9.8 is probably the easier one. So let's start there. Well, 10, 11, 12. So 9 something would be like, if I had another line here, it'd be 9. So 9, halfway would be 9.5. So 9.5. So 9.8 would be like over here somewhere. So I'm going to just make a point. It's going to be close to 10. And I'm going to call this guy 9.8. Now, 4 square roots of 8. What this means, for those who don't know, it is 4 times the square root of 8. So you have to do the square root of 8 first, figure out what that thing is as a decimal, and then multiply by 4. Okay? 8 square root, big ugly number, 2 point something, times by 4 equals 11.3. Okay? Another way we could have done this is, and it would have been a little bit less accurate, we could have estimated, we could have rounded this. The square root of 8 is almost 3. Because you've got square root of 9 and square root of 4. This pen does not like writing 4s. So, square root of 4. So this square root of 8 is almost square root of 9, which is 3. And 4 times about 3 would be about 12. Now that's not very accurate. Using the calculator was much better. I mean, we got 11.3. So if I'm going to do this, I would probably do it using calculator if you have one available. So 11.3, let's see, 11, this again would be 11.5. So 11.3 would be less than that, probably about here. Or actually, I should label it the right way. This would be 4 square roots of 8. But that is 11.3 roughly, and that's 9.8. The easiest way to do this will be with decimals. So if you ever have something that's not a decimal, I'd recommend you change it to a decimal. For example, there you go, negative square roots of 3. I have no clue what that is. It's going to be small. Let's see. 3 square root, and it would be a negative, estimating 1.7. And that's negative 2.7. Alright, so let's see here. If that's negative 2, 1, 2, 3, 4. So this would be halfway. So this would be negative 2.5. So negative 2.7 be someplace in between here. For those who can see this, this would be counting by 1/4. So this would be negative 2.25, 2.5, negative 2.75. So negative 2.7 would be about here. Less than negative 2.5, but bigger than negative 2.75. And this pen is starting to annoy me. Negative 2.7. Just have to write slow. Alright, so now we have this approximately negative 1.7. It's about negative 1.7. Well, negative 1, 1, 2, 3, 4. Negative 1 would be over here. So this would be negative 1.5. And so negative 1.7 would be here. Negative 1.7. Just write slow. And that's what I would do. You have to look at the graph they give you, the numbering they give you, the scale that they're using. Here, I can figure out that they're counting by 0.25. 0.25, 0.5, 0.75, whole number. Here they're counting by 0.5s. 10, 10.5, 11, 11.5, 12. Look at the scale they're using and the numbers you're given, and locate where they would be on the number line. Here are 2 to try. Oh, and one other, or I guess 1 for me to try and then 1 for you to try. But one other thing to mention here is you're never going to get exactly the right spot. And you're not supposed to. Now, obviously you should be close, but you're not expected to get the exact right spot on the number line. So this is kind of some more estimation. You're trying to get close. You're trying to figure out where it is. But don't worry yourself that you're exactly on the right spot. Now, if the dot's supposed to be here and you put your dot over here, well, that's a problem. But if you're off by like a centimeter or half a centimeter, if it should be here and you put it over there, no one's going to complain about that. But just make sure your answer is obvious about where the answer should be. All right, so I'm going to do letter C, and then I'm going to have you do letter D here in a second. So let's block that off so we don't get ourselves confused. Letter C. So this guy, 5.82 or 5.832. Well, he'll be, I don't know, someplace in this ballpark. He's at the end of the 5s, almost 6. This square root of 28, I don't know. Let's see. 28 square root 5.29. Okay, so 5.29, let's see here. 1, 2, 3, 4, 5. So each number between 5 and 6, there's 5 spaces. I can show you a little trick. Between each number, you're cutting it into, you're dividing it by 5 spaces. That's how big each space is, 0.2. So 0.2, ooh. So it'd be 5.2, 5.4, 5.6, 5.8. So 5.832 would be like just over 5.8. And 5.29, well, if this is 5.2, and this one would be 5.4, 5.29, well, 5.3 is here, 5.29 would be just a little bit less than that. So that's what I'm saying. It's estimation. You're just trying to get close. In fact, this 5.832 is probably a little bit too far to the right, but I don't care. It's close. It's ballpark. Go ahead. Try letter D now. So you have the square root of 9 and the square root of 12. Pause the video. Do the problems. Take your time. When you're ready to continue and check over the problems, hit play, and we'll go through them together. Okay. So first thing I'm going to do is I'm going to change both this square root of 9 and square root of 12 to decimals. So 9 square root is 3. Well, that one's easy. That's right there. That is the square root of 9. Okay. 12 square root 3.46. 3.46. Alright, let's look at their scale. From one number to the next, there are 3 spaces. So one number is being divided by 3. That's how big each space is, 0.33. So this would be 3.33 and 3.66. So 3.46 would just be, I don't know, someplace in between here. I'm just going to put it in the middle. That's about the right place. So what this does for us is later on, if I said, what's bigger, square root of 12 or square root of 9, you can go, oh, it's the square root of 12. You can tell by placing the numbers on a number line, which is something you do need to be able to do. And you could also tell just by comparing the decimals, which is also something you need to be able to do. One of the skills on the PSSAs, it actually says students should be able to place rational and irrational numbers at their locations on a number line. That's what this is. Example 3. In this example, all we're doing now is just looking at the two numbers we're given, and we want to be able to tell which one is bigger or smaller, or are they the same? So we're going to fill in with either a less than, greater than, or equal to. Letter A. Now, we said at the beginning of the lesson that the easiest way to compare two numbers is with decimals. So if I just change everything to a decimal, it's going to make my life much easier. So let's do that. Clear, 37 square root equals 6.08. 6.08 compared with 6.9. Hopefully, you can look at those two numbers and very simply tell that 6.9 is the bigger number. If you can't look at that and tell, here's how you do it. Once you have two numbers as decimals, you set them up with the decimals lined up, and you look at them one digit at a time, one number at a time. So the 6's are the same. Move to the next number over. Between 0 and 9, 9 is bigger, so that's the bigger number. It doesn't matter that this guy has two digits and this bottom one only has one. You look one number at a time until you find a difference, and then whichever one has the bigger number is the bigger number. Okay? Letter B, 5 and 1/4. So I know this off the top of my head, but if you don't, divide your fraction. 1 divide 4 equals 0.25. So this becomes 5 is the whole number, 0.25 is the decimal, and square root of 14. 14 square root, 3.74. So now, that's simple. The 5 is bigger. 5 point something is going to be bigger than 3 point something. So if I give you $5 and some change, and you had some $3 and some change, my amount of money is going to be bigger because I've got $5 compared to your $3. So using those whole numbers can save you some time. So 5 and 1/4 is going to be bigger than the square root of 14. I'll do one more example here, and then I have one for you to try as well. Pi. Most people remember or know that pi is 3.14. Now, we know that's a whole bunch of extra digits, but it doesn't matter. That's probably close enough to do this problem. Square root of 15, on the other hand, 15 square root 3.87. Now that we have two decimals, well, clearly 3.8 is bigger than 3.1, so that square root of 15 is the bigger number. I would like you to try letter D right now. Do the problem, pause the video, you're ready to continue, hit play, and we'll go through it together. Alright, so 7 is simple. It's just 7.0 if you're trying to write it as a decimal. 35, 5.91. So comparing those two is now easy. 5.9 is going to be less than 7.0 because 5 is less than 7. So it opens towards the bigger number. Example 4. Now we've reached kind of like the main idea of this lesson, in my opinion, is now we have ways to compare numbers. We want to be able to put them in order. So given a list of 4 or 5 numbers, both rational and irrational, can you take those numbers and put them in order? Can you tell which is bigger, which is smaller? The way we're going to do this is the same way we did the last examples. We're going to take our big, ugly mixed bag of numbers. We're going to change them all to decimals, and then we just put the decimals in order. So let's do that. Starting with square root of 17, 4.1. 9 over 2. That's going to be 4.5, but just to show you, 9 divided by 2 is 4.5. 3.89 is already a decimal, so we don't have to do anything to that. Square root of 9 is 3. That's from our perfect squares we did at the very beginning of the lesson. And 0.1 repeated is just 0.1 repeated. 1, 1, 1, 1, 1, 1, 1. So now you have all your numbers as decimals. We do the problem. So let's see here. The smallest of these, I'm looking at the whole numbers. 4, 4, 3, 3, 0. The smallest is this guy. So I'm going to put 0.1 repeated as the smallest. So he is the smallest. Now, the next one's 4, 4, 3, 3. These two have the same whole number, but this is a 3.8 and this is a 3.0. So that 3.0 is smaller. 4, 4, 3. The 3 is going to be smaller. 3.89. Now, 4.1 or 4.5. Well, if you're going for the smaller one, it's got to be the 4.1. Oopsie. And the 4.1 came from the square root of 17. And the 4.5 came from 9 over 2. Now you might be asking yourself, how would you do the same problem if you did not have a calculator? If maybe you're doing your problems at home, you don't have a calculator that has square root, or a test or quiz or something that's a no calculator problem. Well, it's going to be pretty much the same. You would estimate this square root of 17. So, square root of 17 is between those two. That's 4, that's 5. So square root of 17 is almost 4. And then 9 divided by 2, you can do that by hand. Top number goes on the inside, bottom number goes on the outside, add a decimal, add a 0, and you're going to get 4.5. See? 4.5, and that's 3.89. Square root of 9 is just straight up 3. And you have 0.1. So now out of this, you'd get the exact same order. I would still say this is the smallest, 0.1, followed by the 3, which was the square root of 9. So first, second, this would be third, the 3.89. And then between about 4 and about, or 4.5, the about 4 would be smaller. So the square root of 17, and finally the 4.5, which was 9 over 2. So we can get the same answer with or without a calculator. Obviously, with a calculator is easier, but it's not undoable without a calculator. I'm going to do letter B without a calculator. And then I'll check it with a calculator. So let's check. First thing I'm going to do is I'm going to try to get everything to a decimal. So this guy is just 8.43. It's already a decimal. 8 3/5. Well, so that's going to be 8 point something 3/5. Top number goes on the inside, bottom number goes on the outside. Add a decimal and some zeros. 5 goes into 3 0 times. 5 goes into 30 6 times. 6 times 5 is 30. Subtract. Bring down. 5 goes into 0 0. So 8.6. That's what the 3/5 gave me. Gave me 0.6. And we have 8.1 and square root of 80. The numbers around square root of 80 are 81's the first one in my head. That's bigger, so smaller. See, that's 9. So smaller would be 8 at square root of 64. This number is almost 9. It's just about there. So I'm going to put about 9. And then we just finished the problem. So now we're going to put them in order from least to greatest. 8.1 is the smallest, followed by this 8.43 thing, or 8.43 repeated, not thing, repeated. And then the 8 3/5. And then the square root of 80, because it's almost 9, that is the largest square root of 80. Now, if I use my calculator to double check, well, the only one I really have to check for myself would be this square root of 80. All the other ones I know because we did it by hand. So 80 square root 8.9. Yeah, 8.9 is going to be bigger than 8.1 and 8.6 and 8.4. So no problems there. We are able to do it just fine without a calculator. Please do letter C. Same thing, put them in order. So you have square root of 20, 4.9, square root of 23, 4 1/10, 4.1 repeated. Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Alright, so I'm going to do without a calculator. I like a challenge. So square root of 20, in my head I'm seeing 16 and 25 as my perfect squares. Square root of 20, that's almost smack dab in the middle between 16 and 25. I mean, it's 4 numbers away from here and it's 5 numbers away from here. So it's almost in the middle. So I'm going to say between 4 and 5, I'm going to call it a 4.5. That's an about. It's about 4.5. We've got a 4.9. Now, 23 is between the same two numbers, but that one's closer to 5. So I'm going to call that about 5. 4 1/10. Let's see, that gives me 4.10 divided into 1 goes in 0.1 time remainder of 0. So 4.1, and this is 4.11111 repeated. So let's see. Smallest, 4.1. Now, if you have a hard time telling between this 4.1 and this 4.11, here's what I would do. 4.1, 4.11. 1, 1, 1, 1, 1. If you look at them one number at a time, 4s are the same, 1s are the same. This next digit over, you either have a 1 or a nothing, a 0. And 4 point nothing is smaller than 4.1. So the 4 and 1/10 is the smallest. Followed by the 4.1 repeated. So we use this one and that one. So we have these first three. Out of those first three, the 4.5 is going to be the next. So I'm going to call that a square root of 20. And now I'm down to this, 4.9, or about 5. That one's going to be a little tricky. With a calculator, we could whip it out really easily. You just type in square root of 23 to figure out what this number actually is. But without a calculator, it's a little bit harder. In my head, I'm pretty sure that it's going to go 4.9 is going to be bigger than the square root of 5. Let's check. I'm sorry, square root of 23. 23 square root is 4.79. So as a decimal with a calculator, 4.79. The way that I came up with that I figured that this 4.9 was going to be bigger than the square root of 23 is if it was like square root of 24, I would have been pretty sure it might have been a 4.9 something. Because it was square root of 23, it's a little bit farther away from 5. I think it's not, I mean, it's obviously not going to be 5, and it's probably going to be a little bit farther away than 4.9. And knowing something like that just comes from, well, experience and having a good number sense, having a good idea how far numbers are away from each other. But that problem was definitely made easier with the use of a calculator. Let's see a few applications of this. This problem says the formula to find the circumference of a circle is c equals 2 pi r, where c is the circumference and r is the radius. If a circle has a radius of 3 inches, what is an approximate area? I promised myself there'd be no typos, but I still messed up. What is the approximate area of this circle? Well, let's see. We're just trying to get an approximate, so I'm not going to pull out my calculator and get an exact answer. So let's see. Circumference equals 2 times pi times by the radius. And it says the radius is 3. I know pi is this 3.14 thing. And times by 2 equals the circumference. Now, since we're going for approximate, I don't even need this 0.14. Can't I just estimate pi to be like around 3? It's pretty darn close. So if I'm trying to get just an estimate, an approximate, 2 times 3 times 3 gives me 18 inches. That's close enough. That's all we need. We're just trying to approximate. Letter B. Jasmine has $2 3/4. Kayla has square root of $5. Trisha has 2.9 repeated dollars. And Kaylani has 37/20. If these girls need a total of $11 to buy a board game that they want, would they have enough money? So what the problem is saying is that if all of these numbers together is equal to $11 or more, so they have to have at least $11 to buy the board game they want. So if I would take this number plus this number plus this number plus this number, is that number at least $11? Can they buy the board game that costs $11 is what we want. Well, let's see. This 2 3/4 as a decimal is 2.75. You can divide by hand if you don't trust me, or divide using a calculator, but it is. Square root of 5. I think it's calculator time. 5 square root 2.23. And we've got a 2.9999999. And we've got a 37 over 20. That's kind of ugly too. 37 divided by 20 equals 1.85. And we want to know, with all this money, can we buy this board game that costs $11? Well, let's see. Since we're already using our calculator, might as well finish up using the calculator. So we've got 2.75 plus 2.23 plus 2.99 plus 1.85 equals... Nope. They only have just almost $10. That's not going to be enough to buy this board game. So if the girls need a total of $11 to buy the board game, would they have enough money? No. The total of their money was what? The $9.82. So I have no, they only have $9.82, and they need 11. So that's what I would do. It's much easier to do the math with decimals than fractions. So if you ever have a mixture of fractions and decimals and square roots and anything else, change everything to a decimal, because it's usually pretty easy to change it to a decimal, dividing or taking square root. And then once it's a decimal, then you can do your math with it or compare it. 2 more problems, then we're done. Here's letter C for you to try. It says Nicole owns 2 genetically engineered minions to do her bidding. Minion Dave is 2 times the square root of 23 feet tall, and Minion Toby is 3.97 repeated feet tall. Which minion is taller? I'd like you to pause the video, try the problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see here. Minion Dave is 2 square roots of 23. Well, what is the square root of 23? 23 square root is about 4.8. If you want to round that a little bit, 4.8. Times by 2 gives me 9.6. Now we're still estimating. It's about 9.6. Minion Toby is 3.97 feet tall. So which minion is taller? The one that's 9.5 feet tall or the one that's 4 feet tall? Well, clearly Dave is going to be the bigger minion. He's pretty huge. He's 9.5 feet tall. So which minion is taller? Minion Dave is taller. And last problem of the day, letter D. The lengths of the sides of rectangle A are square root of 8 centimeters and 4.16 centimeters. Rectangle B has side lengths of 3 8/9 centimeters and 5 centimeters. Approximately, how much larger is the area of rectangle B than rectangle A? And I fixed the typos if you saw them. So, pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so we're trying to find out which one has a larger area, rectangle A or rectangle B. So let's start with rectangle A. To find the area of a rectangle, area is length times width. So, the sides of rectangle A are square root of 8 and 4.16. So I'm going to put 4.16 times by, what is the square root of 8? 2.82. 2.82. And if I would multiply those two things together, that would give me my area. So let's see. 4.16 times by 2.82, approximately 11.73. Now, understand that this answer is approximate. It is not exact. We rounded a bunch of different things. We rounded this number here, which makes our answer different, and we even rounded our answer a little bit. So, hopefully, the area for rectangle B is not even close to 11.73. Hopefully it's like 5 or 8 or maybe even like, yeah, something just far away. So length times width. The length is 5. The width is this 3 8/9. 8/9, if you remember from the last lesson, as a turning a rational number, something over 9 into a decimal, is going to give us 0.888888888. It's a repeated decimal. So we have 3.8 repeated, but I'm not going to type in the repeated. And let's multiply. 5 times 3.8 equals 19. I would say that's far enough away to make sure that we know that rectangle B is going to be quite a bit bigger than rectangle A. We got this guy to be approximately 11.73. Rectangle B is approximately 19. Rectangle B is bigger. Approximately how much larger is the area of rectangle B than rectangle A? So we know that rectangle B is bigger, but we didn't answer the question. How much bigger is B than A? If you're trying to find out how much bigger something is, or how much smaller, or what is the difference, you're going to subtract the two things. So I'm going to take rectangle B minus rectangle A. 19 minus 11.73, and that will tell me the difference. So let's do that. 19 minus 11.73. I missed my decimal, missed it again. There we go. 7.27. So approximately how much larger is the area of rectangle B than rectangle A? Well, it's approximately 7.27 label centimeter squared larger than rectangle A. So we found the area of rectangle A by using the area formula and estimating the square root of 8. We found the area of rectangle B by using the area formula and estimating this 3 8/9. We then said that rectangle B is larger. Obviously, 19 is bigger than 11.73. The question was, how much larger? Because it was asking how much larger, or what is the difference, we had to subtract the two. So we took 19 minus this 11.73, and we found that the difference is 7.27. So rectangle B is 7.27 centimeters squared larger than the area of rectangle A. All right, so for our summary in your Collins writing page in the front of your packet, this is Lesson 2, Type 2, which means I'm grading on correctness, not just completion. Make sure you have a good answer. The question is, how can I order and compare rational and irrational numbers? This was essentially answering the essential question from the lesson today. So how do you order and compare rational and irrational numbers? How do you put them in order? How can you compare them? All right, so answer that question. That's your summary. Pause the video if you need to. When you're done, that's the end of the lesson. Thank you for watching. Goodbye.